Hello friends, in today's class we'll be studying about another aspect of prerequisites that are required for the chapter Engineering Materials and Applications. The prerequisites are capacitor and capacitance. So let's begin. Now, a capacitor, as you all know, is an electric condenser, which is a two-terminal electric component and has the ability to store energy in the form of electric charge. Now, all the keywords are important. So it's an electric condenser and a two-terminal device. It has the ability or a capacity to store energy in the form of electric charge. Well, this is nothing but as an application of dielectrics and polarization. Now, we see here it's a capacitor, and the type of the capacitor is a dielectric capacitor. Now, what do you mean by a dielectric capacitor? Well, as you can see, there are two metal plates and there's a blue colored dielectric introduced between the plates. If I do not have this blue colored dielectric, then it would be called just as capacitor. But since I have a blue colored dielectric medium in between them, they are called as dielectric capacitor. And of course you have the conducting wires as well. But this is not how it is packaged. Well, it is packaged in the form of a cylindrical capacitor, wherein this is the value as you can see, which is 1000 microfarads, and the voltage rating is 6.3 volts. So what does these values mean? Well, this is nothing but as the total amount of electricity which it can store at a given value of voltage. So what are the significance of this? So how would you actually define a capacitor? Well, just to give you a simple example and a simple prototype, how does a capacitor works? Let's imagine I have a bucket of water, but the problem is the bucket of water is being filled by a tap from which water comes in the form of drops. So how long would it take for the bucket to get filled? Of course, it would take a longer time. Why? Because the water is coming in the form of drips. Now, if I want to use this water, maybe let's say suppose for bathing, I cannot use this. Why? Because the water collected would be very less. So what I need to do? I need to wait for certain time. And let the bucket full. Now, after a certain point of time, let's say suppose the water level reaches here, and now this is significant enough for me to make any use of this. So if I want to make a use of this, I would directly pour this water out in a short period of time, and then I can use this. So this is how a capacitor works. A capacitor is nothing like an empty bucket which gets filled with amount of electricity or the current. It keeps on storing the current within itself till the point when the capacitor's capacity does not get completed. So once the capacitor gets completed with its capacity to hold any more electric field or any more electric current, it does not charge further. And then if you want to use this, it is going to give you that amount of energy in a very short span of time. A simple example would be your mobile phone's flash camera. A flash camera works on the same principle as capacitor. Your battery gives charge to that capacitor, which in turn gives power to your flash camera. If you observe, your camera flash turns on for a very few seconds and then again turns off. And if you want to do a continuous flash again, it would take some time for the capacitor in it to charge from the battery and then give you a shot. So this is how a capacitor works. So the ability of capacitor to store energy in the form of electric charge is known as its capacitance. So capacitance is nothing but as the amount of charge or the energy that a capacitor can store in itself. Now, let's see a working of a capacitor. This is how a diagram of a capacitor looks like. The green colored are the charged electrodes, or you can also call them as metal plates. Now, we call them electrodes because the conducting wire has positive charge from one side and negative charge from the other side. Since the plates are metal, the positive charge gets transferred to the positive plate and the negative charge gets transferred to the negative plate, and hence they become as electrodes. Now, having positive charge on the metal plate gives rises to a positive charges on the side of the positive plates, as you can see here. Similarly, negative charge on the metal plate gives rise to negative charges on the metal plate, and therefore an electric field is generated which rises from the positive side and terminates on the negative side. This is nothing but as the electric field. Now, the formula for capacitor is given as C is equal to epsilon AK by D, where C is the capacitance, epsilon is the permeability, now what is permeability? Well, permeability is nothing but as a constant value which allows the electric field to traverse through a medium. A is the area of metal plates. Now K is nothing but as dielectric constant. Now do remember K for air is E1. So whenever I have air or vacuum in this case, we will always have K value as 1. Similarly, D is the distance between two plates. So here in this case, this would be my distance D. Now, as you can see here, they have two metal plates. One is positively charged, another is negatively charged. But in this first case, I can see E is equals to V by D. Or I can say C is equals to epsilon A by D. Now what is epsilon 0? Well, this epsilon 0 is nothing but as permeability for vacuum or free space. Whereas in the case of a dielectric, as you can see here, I have introduced a dielectric medium between the parallel plates. This increases my capacity by a factor of K. As you can see here, C is equals to epsilon 0 A by D. If I call this as C A, so here this C becomes equals to K times of CA. So having a dielectric medium or a dielectric material introduced between the capacitor increases the capacity of the capacitance. Now, how does this take place? Because it's a very simple concept. You can understand it this way. The dielectric material has the electric field to get dissipated inside it. So basically, if I have nothing in between, my field is directly going to go from this plate to this plate. It would be a direct transition. Whereas if I have a material in between them, the field will take a while to get from top to bottom, thereby increasing the capacity or the amount of charge that it can store within the capacitor. Thank you.